The development of artificial intelligence applications in self-driving cars to detect unusual situations and make appropriate decisions. The emergence of self-driving cars has revolutionized the automotive industry, with artificial intelligence, AI, playing a crucial role in their development. AI applications in autonomous vehicles are designed to detect and analyze real-time data from the vehicle's surroundings, enabling them to make informed decisions and navigate safely on the road. This article explores the progress made in the field of AI applications in self-driving cars, specifically focusing on their ability to detect anomalous situations and make appropriate decisions. One of the key challenges in autonomous driving is the ability to accurately perceive and interpret the environment. AI algorithms, powered by deep learning and computer vision techniques, enable self-driving cars to detect and recognize objects, such as other vehicles, pedestrians, traffic signs, and road markings. By analyzing sensor data from cameras, LiDAR, and radar systems, AI applications can build a comprehensive understanding of the surroundings and identify potential hazards. Furthermore, AI applications in self-driving cars are trained to detect anomalous situations that deviate from expected patterns. Through continuous learning and data analysis, these systems can recognize abnormal behaviors of other road users, unusual road conditions, and potential safety risks. For example, AI algorithms can identify erratic driving patterns, sudden lane changes, or pedestrians in unexpected locations. By detecting these anomalies, self-driving cars can take appropriate actions to ensure the safety of passengers and other road users. In addition to anomaly detection, AI applications are equipped with decision-making capabilities. These systems can assess the detected anomalies and determine the most suitable response in real time. For instance, when encountering a vehicle suddenly swerving into its lane, a self-driving car can make decisions to brake, change lanes, or communicate with the other vehicle to avoid a collision. The decision-making process in autonomous vehicles relies on complex algorithms that consider various factors, such as traffic rules, road conditions, and the behavior of other road users. The development of AI applications in self-driving cars also benefits from advancements in machine learning and predictive modeling. By analyzing large amounts of historical data and real-time sensor inputs, these systems can learn from past experiences and predict potential outcomes in different scenarios. This predictive capability allows self-driving cars to anticipate potential dangers and take preemptive measures to avoid accidents. Moreover, the integration of AI applications with cloud-based systems enables self-driving cars to access real-time data and receive updates on road conditions, traffic congestion, and weather conditions. This connectivity enhances the decision-making process by providing up-to-date information and enabling coordination with other vehicles or transportation infrastructure. For instance, self-driving cars can adjust their routes to avoid congested areas or receive notifications about road closures or accidents ahead. Despite the significant progress made in AI applications for self-driving cars, challenges still remain. Ensuring the safety and reliability of these systems is of utmost importance. Rigorous testing, simulation, and validation processes are required to minimize the risk of accidents or failures. Additionally, ethical considerations, such as decision-making in complex moral dilemmas, need to be addressed to ensure that AI-powered self-driving cars prioritize human safety and well-being. The ongoing development of AI applications in self-driving cars focuses on refining their ability to handle complex and dynamic driving scenarios. Advanced AI algorithms are being designed to improve decision-making in challenging situations, such as navigating through heavy traffic, handling adverse weather conditions, or encountering unexpected road construction. These systems continuously learn and adapt from real-world experiences.